let's look here. So we have the equation, correct? Can everyone type that into their calculator, please? Everyone use calculator. Type it into their calculator.
Concave down.
Okay.
It's got a concavity at, I don't know.
Yeah. So we see that it has one maximum. We agree?
Yes.
Can everyone go find that maximum? You might need to make your window Y max bigger, but go find it.
12. Because I used the maximum.
So we are getting a maximum. Everyone agrees we're getting a maximum at 0.5 and 12.25. Guys? Yes? Do the check for me. In the backpack or something. It's just calling your name where it is.
Oh, there it is. Yeah.
All right. Did you guys see 0.5 anywhere else in front of your face? I hope you do.
If the max is 12.25.
The coordinate of the maximum is 0.5 and 12.25. You got the Y intercept.
How?
All right.
You 1 divided by 2? What's that?
Second trace maximum. Then you go on the left side and the right side,
2.
and then enter.
What are we doing?
Okay. On your page, are you seeing 0.5 anywhere? Then I ask you to find critical numbers. What is it? It's the critical number, correct? 1/2. Okay, so let's see that. So we go f prime of x equals 1 minus 2x. We said to get the critical numbers, we set the first derivative, which is the tangent slope equal to 0, because wherever we have tangent slopes equal to 0, we have max, mins, or possible points of inflection, correct? Because that's where they happen at. So when I solve this one out, I get 2x equals 1 and x equals 1/2. 1/2 is the same as 0.5. Can you see that? Now, how would we know if it's a max or a min? This is what today's lesson is. So, I make myself a number line. The number line has arrows on it because the number line represents the domain of the original. The original function is a quadratic. Do we agree? So if the original function is a quadratic, its domain is negative infinity, positive infinity, correct? So when I go to do a number line here, I make my number line contain my domain. Negative infinity, positive infinity. Should be writing this down. You don't even have your binder. All right. So this is your critical number, which is 1/2. We agree? Now we run test points. Because, guys, if I have a quadratic that looks like this, if I draw tangent slopes on this graph, watch what happens. So when I draw a tangent slope here, it's a positive tangent slope. Positive tangent just means in one spot, right? Positive tangent slope, still positive. What happens here? 0. Then what happens here when it's decreasing? Negative tangent slopes. And tangent slopes are the first derivative, correct? So if I run test points on either side of 1/2, if they come out as negative, then it's decreasing. If they come out as positive, it's increasing. Because we know that wherever f prime of x is less than 0, the function is decreasing. And wherever f prime of x is greater than 0, the function is increasing. That's the first derivative test. So let's run a value. What's between negative infinity and 1/2? The easiest one for me to run is 0. Okay? You can run anything that falls between there, but 0 is the easiest one. If I have 0 as an option, I always pick it. 1, if I have 1 as an option, I pick it. So you plug it back into the first derivative. Okay? Here's my first derivative equation. We agree? So I'm going to find f prime of 0. So I get 1 minus 2 times 0, which is negative 1. Which is not negative 1, which is 1. Positive 1. Do I actually care that it's 1, or do I just care that it's positive? Just care that it's positive. Every value that I pick between negative 1/2 and negative infinity that I plug into the first derivative will come out as positive in that area. So if it comes out as positive in that area, what's happening between these two values? The graph is doing what? Increasing. Wherever the f prime is greater than 0, it's increasing. So I know it's increasing here. And I know this one I have to test out. So anything between 1/2 and infinity, I'm going to test 1. So I'm going to do f prime of 1. So I get 1 minus 2 times 1. So I get negative 1. So it is decreasing. Now the graph, what did it do on the left side of 1/2? It increased. And what did it do on this side? Decreased. Now the first derivative test tells us that if it increases to decreases, what are you going to get? A max or a min? If you increase to decrease, max. And if you decrease to increase, you're going to get a min. Now there's one other thing you could get. If you increase to increase, point of inflection. If you decrease to decrease, point of inflection. Sometimes you decrease to decrease and it's not a point of inflection because actually what's in between them is an asymptote. So you do have to watch. Sometimes you do get asymptotes that fall in there. So, and it'll come out as a critical number. So this one increases to decreases. So I know that this is a maximum. And I go f of 0.5 and I plug it into the original. I get 12 plus x minus x squared. So I get 12 plus 0.5 minus 0.5 squared. And when I do that, I get 12.25, which is the maximum I found on my calculator. Do we agree? So did I need my calculator to find the maximum? No. The other thing they'll ask for is they'll ask for intervals of increase, decrease. So the intervals of increase we already have. Where is it increasing? Between what and what? Where? Negative infinity and 1/2. That's a domain, just rounded brackets, because it's not increasing at negative infinity, right? So we put rounded brackets. And then intervals of decrease. One-half to infinity. So these questions are not hard if you can get the critical numbers. But I told you the questions are completely impossible if you can't get the critical numbers, because then you can't set up the number line, you can't run test points, you can't get intervals of increase, decrease, you can't get maximum. It's a disaster. Okay?
For a test, you do all that to prove that.
Just depends on what I ask for. Sometimes I just ask for intervals of increase. Sometimes I just ask for intervals of decrease. Sometimes I ask for max and min. Sometimes I ask for points of inflection, which we'll do in the second derivative. Concavity, stuff like that.
You ask for something that's not very nice and easy to do.
You can ask for whatever I want.
Back to this polynomial.
Okay, so this one up here, you guys found the critical numbers for, so let's test it. So we get g prime of x equals 3x squared minus 3. Take a 3 out, and I'm left with x squared minus 1. And so I get 3x plus 1, x minus 1. And I set it equal to 0. We agree? So what are my critical numbers?
Positive and negative.
X equals plus or minus 1. So when I go to do the number line, I know plus or minus 1 is on that. That's true. But I have to go back up to the question and say, what is the domain of this function? So this is a cubic function. What is its domain? Every cubic function's domain. Every polynomial function's domain. Negative infinity, positive infinity. So when I go to do my number line, I have a negative infinity, positive infinity, And I have a -1 and a 1. Do we agree? Now we have to run test points. And what you could run it into this one, right? You could put it into there. But what I always try and do is I try and run my test points into my most simplified derivative. So this is the most simplified derivative I have, correct? The 3x plus 1, x minus 1. So that's what I'm going to put it into because I just want signs. And sometimes you don't get calculators. So I'm going to run a test point of below -1. I'm going to run -2. So that's going to be my test point. So I'm going to find f prime of -2. So that's going to equal 3 times -2 plus 1 times -2 minus 1. Now, do I actually care what the number is or just the sign? Just the sign. So let's talk about this. We have a positive 3 times a negative number times another negative number. What am I going to end up with? A positive. Do I care what the number is? No, unless I'm drawing the first derivative, which I would need an x and then a y for the derivative. I don't care what the number is. I care what the sign is. So this is going to be a positive times a negative times a negative. So I end up with a positive. Okay? Then I have to run another test point. So between -1 and 1, what's a good one to track? 0. So I'm going to do f prime of 0. So I'm going to get 3 times 0 plus 1 times 0 minus 1. So I get a positive times a positive times a negative. So what's this one? Negative. Do you see how I'm running test points? You have to show the work to it too. And then say I run 2. So now I need f prime of 2. So I'm going to get 3 times 2 plus 1 times 2 minus 1, which is a positive times a positive times a positive, which is a positive. Now it doesn't always go positive, negative, positive. It could go positive, negative, negative. It could go positive, positive, positive. Let me just be reflecting on. So I know what's happening at these values. So at -1, I have increasing to decreasing. So I like to visualize it. I have increasing to decreasing at -1. So what do I have there? A max. And then at +1, I have decreasing to increasing. So what do I have? A min. So if I want the max or min, that's just where the x's are of the max and min. How do I get the y's? Where do I plug them back into? The original, because I want the max and min on the original function, correct? So I'm going to go f of -1, and by f I mean g. I don't know why I'm using f's. Goodness gracious, it's all g's. G of -1 equals -1 cubed minus 3 times -1 plus 2. And so I get -1 plus 5, which is 4. So I have a maximum at -1, 4. Correct? And I'm doing g of 1. So I get 1 cubed minus 3 times 1 plus 2. So I'm going to get 1 plus 2 is 3 minus 3 is 0. And this is a minimum. Can everyone type the original into the calculator, please? And find your max and min using your calculator. Okay, so our max and mins match the calculator. The other thing we have to write is our intervals of increase, decrease. So our intervals of increase are -infinity to -1, and then we say or, so we put a union, 1 to infinity, and our intervals of decrease, or just interval of decrease, I guess, is -1 to 1. Let's discuss it. So, g prime of x equals 6x squared minus 6x. What can I take out? And I'm left with x minus 1 Now that's the most reduced it can be, correct? We agree? Okay, then we make the most reduced we can be, and then we set it equal to 0 to get our critical numbers. And then we get x equals 0 and 1. I don't know any profs who are going to be like, you need to write out 6x equals 0 and x minus 1 equals 0 in order to get full marks. Like 30-1 diploma, okay? So, you can go from there to there. You don't have to write equal to 0.
0, 1.
Yes. So, then we have to go back. What is our domain? Negative infinity, positive infinity. So once again, we have that number line. We're not always going to have the perfect number line from negative infinity to positive infinity. Like if I get a radical, radicals are greater than or equal to 2 or 4 or whatever. So then you're going to start at 2 or 4 and go greater, or 3 and 5 and go less, right? Or you might be between two values. So these arrows are just full because the domain is XY. Now we have 0 and we have 1. Okay. So then we have to run test points. So our test points, we can run like 0.5. And honestly, it doesn't matter. If you use the most reduced form of your derivative, it's really easy even with decimals to pull numbers, correct? So if I use -1 or 0.5, it doesn't really matter. But I'm plugging it into this one, right? So I'm getting 6 times -1, and then -1 minus 1. Well, 6 times -1 is -1. -1 minus 1 is negative, so what do I end up with? A positive. Then I have to pick between 0 and 1, so 0.5. So I can do g prime of 0.5. And then I get -6 times 0.5, which is a positive. And then 0.5 minus 1, which is a negative. So what do I get? Negative. You see how I don't actually care what the number is? I just care what the sign is. Any number I pick between 0 and 1, not 0 and 1, they'll result in zeros. So anything between 0 and 1 should result in a negative answer because it's decreasing, so negative tangents would be found there, correct? And then greater than 1, g prime of 2, let's say, I would get 6 times 2, which is positive, and then 2 minus 1 is positive. Positive times with positive is positive. So I know that when I go from increasing to decreasing, I get a max. And when I go from decreasing to increasing, I get a min. G of 0 equals 2 times 0 cubed minus 3 times 0 squared, which is 0. So at 0, 0, I have a max. At G of 1, it equals 2 times 1 cubed minus 3 times 1 squared, which is -1. And so at 1 and -1, I have a min. And then my intervals of increase are negative infinity to 0, or 1 to infinity. And my intervals of decrease are 0 to 1. So we'll do one more polynomial, but then we're moving on, because it's not always going to be polynomial. If it was always polynomial, it's like to be pretty darn easy. Rational, radicals, exponentials, logs, straight. They're all round?
Yes.
They're all round because at those actual values, you're not increasing, decreasing. So you can't equal negative infinity, positive infinity. But at 0 and 1, those are equal to 0. They're not increasing or decreasing. That's where maximum min exists. Right? So it increases all the way to 0, but then at 0 I have a max. It decreases all the way to 1, but then at 1 I have a min. And it increases all the way to infinity, and at infinity I can't equal it.
Okay.
That makes more sense?
Yeah.
Okay. All right. Here's one more, and then we're moving on to non-polynomials. Sure, g of x equals 2x cubed minus 9x squared minus 60x plus 82. So we have g prime of x, if it starts writing, equals what? What do we get? Don't all answer at once. What do we get? 6 x squared. My board is minus 18x minus 60. Okay, guys. What can I do next? You can take out, this board is being really awesome right now. Take out a 6. I'm left with x squared minus 3x minus, guys, why are you all talking? I know they're talking is throwing me off. Hey. That doesn't mean I turn around and you continue to talk. X minus 5, x plus 2. So x equals 5 and x equals negative 2. Yeah? Okay, it is a cubic function, so we have a number line. That's negative infinity to positive infinity. We have 2 and 5 on it. We have to run test points, so I'll use a different color. So I'm going to pick 0, so I get 6. 0 minus 5. This board is so awesome right now. 0 plus 2. So it's a positive, negative, positive, which is a negative. We agree? Then I run between 2 and 5, so I could do 3. So I get 6. 3 minus 5. 3 plus 2. So I get plus, minus, plus, which is? What do we get? Negative. And then here we get, is it negative, negative? Yeah. This is positive?
You put 2 equal negative 2 on the number line.
Oh, look at that.
Oh,
Oh, silly me. Yeah, so negative 3. So we get negative, negative. So it's positive. Okay. And then 6. 6 minus 5. Guys, really frustrating when you're talking the entire time. Plus, 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 which is plus. So we have increase to decrease, decrease to increase. So our max is g of negative 2 equals what when you plug it in?
150.
How much? And then the minimum is g of 5. What do you get? Sorry?
Where's what? Where's what? Yes, there's.
Negative what? All right, it's increasing from negative infinity to negative 2, or 5 to infinity, and it's decreasing from negative 2 to negative 5. Negative 2 to 5, sorry. All right, giving you a hard one. Okay, this one's going to have a restricted domain because you have a radical, and you also have to do what to first derivative? Product rule with the chain rule involved. When we have a radical, our domain, the number has to be what? Or equal to 0, because you can take the square root of 0. You just can't take the square root of a negative number. So when you have a quadratic underneath it, it's more complex. You actually have to find out what part of the quadratic is above the x-axis or below the x-axis. This is a linear. When it's linear, it's actually really easy. You just say whatever the heck is under it has to be greater than or equal to 0, correct? You can move the x over, or you can subtract the 4 over. If you subtract the 4 over, you have negative x is greater than or equal to negative 4. And when you divide by negative 1, what happens? Inequality sign flips. So, if you just move the x over first, you would have this, which made the inequality sign flip, because it's close to the x, here it's close to the x. Same thing, correct? If you get stuck, can you not just run a test point? Like, if you don't know if it's greater than or equal to 4 or less than, put a 5 in. 4 minus 5, oh, crud. They get negative 1 underneath. That's no good. So it has to be less than or equal to 4. We agree? We've learned lots of stuff. And then, that's this function. This function is a line. Its domain is XCR. We agree? Or negative infinity, positive infinity. So if this one's domain is negative infinity, positive infinity, and then this one's domain is less than or equal to 4, come on. When we do multiplication of two functions, what do? We take the most restricted domain, correct?
Yeah.
That's what we learned in 30-1. That's why we do composition of functions, or that's why we do multiplication, division, all those things, is for calculus. So, the domain of this function in its entirety, I don't need to put it into my calculator because I know this one is this, I know this one is infinity, so I take the most restricted domain, so this is going to be my domain. So when I go to do my number line, I'm going to end up with a number line that looks like this. 4, board's wanting to quit on me, and negative infinity. Oh my gosh. Yes? So our number line isn't just infinity, negative infinity to positive infinity. And the reason why I need you guys to pay attention the whole time is because I need you to understand why we're doing what we're doing. Because the people who just do steps scare me. So when it comes to a test, steps fall out of your head, right? But if you understand why you're doing it, it doesn't matter what pressure you're underneath, you'll know how to do it. Okay? So reminding us of why that domain is what it is because when we multiply, add, subtract functions, the domain is where both exist. So the most restricted domain of the two. Okay, facts. So we go to do the actual derivative of it. So we have y equals x, and then 4 minus x to the half. So this is f, this is g. F prime is 1. G prime is a chain rule. Remembering that whenever we use a chain rule in our product rule, we are going to be able to GCF. That's the point. Remember? When we have a chain rule in our product rule, we'll be able to GCF that out. And the reason why we need to be good at that is that gets us our critical numbers. Okay. So this one is going to be 1/2. Oh, come on. 1/2 4 minus x to the negative 1/2 times negative 1. Because of the derivative of the inside. So I get negative 1/2 4 minus x to the negative 1/2. Okay. So y prime equals g times f prime. Now I told you that your prof is probably going to do f times g prime plus g times f prime and then make you memorize a different one for the quotient rule. But instead I just do the same as the quotient rule, so you can put a minus in. So don't let that throw you off if they do it in opposite order. Okay? So g times f prime, because it's addition, we can do it in any order we want. And then f times g prime. And then we practiced this before. What can we take out of both of these?
4 minus x.
4 minus x.
Negative 1/2.
The negative 1/2 and 1/2.
-1/2.
Negative 1/2 or just 1/2, it doesn't really matter what you do. If you take out a negative 1/2 though, when you go to run your test points, you have to remember you have a negative starting off, right? So your sign will be different. So we're left with 4 minus x minus x. What's the 4 minus x times? 2. We pulled that half out. So we get y prime equals 1/2 4 minus x to the negative 1/2. And then we're left with 8 minus 2x minus x, so 8 minus 3x, correct? Now, does it matter if something's raised to some weird old, like, negative 1/2 or 3/4 or anything weird like that? You're going to set them equal to 0, correct? Then you raise to whatever power, 0 to whatever power is still 0, right? So that doesn't really affect anything. It's really what's in the brackets. So a half doesn't give me a critical number. 4 minus x to the negative a half equals 0. I would raise this to the negative 2. But it just goes away, right? And it becomes 0. So really, what's inside the brackets is what matters. So x equals 4 is one of my critical numbers. And then 8 minus 3x equals 0. 8 equals 3x. X equals 8/3. Now, if the number is outside the domain, love that it's critical, but it's useless. We wouldn't keep it. So if it doesn't fit on the number line, then that's a critical number that doesn't exist, right? So sometimes you get numbers outside. More often than not, you get critical numbers outside when they restrict the domain. So they can ask for the max and mins between a domain of -2 and 4. So they just cut your domain into pieces, right? So then your max might be outside of that and you don't count it. That's more so when the critical numbers don't matter. Okay, so which one's bigger, 8/3 or 4? 4. 8/3 is actually where the max or min or point of inflection is going to occur. 4 is a critical number because it's where the graph stops. Yeah? So it's not a max or a min. So sometimes where your graph actually begins or ends will show up as a critical number, but it's not a max or a min. So we run test points. What's below 8/3? 0. What's above 8/3? 3. So then we plug it into the reduced, this one. So I'm going to get 1/2, oh my gosh, 1/2, 4 minus 0 to the negative a half, 8 minus 3 times 0. Anything to a negative just makes it a fraction, correct? Negative doesn't make it negative. A negative exponent makes it a fraction, still positive. So a lot of people fall for that. They'll be like, oh, the number's negative. No, it's 4 flipped, so it's a half, and it's square rooted, so it's 2, right? So this is technically the square root of a quarter, which is a half. I don't know why I said 2. Half. Anyways, this is positive, this is going to be positive, and this is going to be positive, so we get positive. Then I use 3, so I go a half. Oh my gosh. 4 minus 3 to the negative a half. And then 8 minus 3 times 4. 3 times 3, don't know why I said 4. All right, so I get positive, positive, negative, which is negative. So this is increasing to decreasing, so it's a max. When x equals 8/3. Did anyone figure out the y? I'm going to... 3.08. And then increasing from negative infinity to 8/3. And decreasing from 8/3 to 4. And this time my 4 is equal to, right? Because it actually has that square. Well, actually, it's still round.